Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 4B. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th of December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Please note that each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all kindly adhere to the timeline and as well stay with us connected till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of this session, Dr. Amit Thakur. Dr. Amit Thakur is a professor and head in the Department of Computer Science and Engineering in the Faculty of Engineering and Technology, Charusat University, Gujarat, India. He has published 3 books in the area of data mining. He has also served as a member of the technical committee at various national and international journals and conferences. His current research interests include machine learning, deep learning, and embedded deep learning. Thank you so much, sir, for joining us for this session. I would like to request you to give any opening remarks before we commence the session. Do we have you here with us, sir?
I think to all the participants and expecting a quality presentation from all of you. We may start.
Thank you so much, sir. So, without further ado, let's begin the session. For the first presentation today, I would like to call Ma'am Bhavika Patel to kindly present her paper titled SHAP Driven Equivalent Deep Learning Model for Hyperspectral Pathogen Identification. Do we have you here with us, ma'am?
Yes, ma'am.
All right, I will stop sharing. Yes, you can share your screen now.
Is ma'am screen my is visible?
Yes, ma'am, your screen is visible. You may start.
Okay. So good morning, everyone. Today I'm going to present so some of my research work regarding the ASAP-driven equivalent deep learning model for hyperspectrum pathogen identification. With me, I have my co-authors, Dr. Jitendra P. Chaudhary, sir. Uh, which is this one is the outline of my presentation: introduction, literature review, proposed approach, experimental results, conclusion, and references. Why we have used the hyperspectrum images data? Because they enables the non-destructive and early detection of the plant disease. In that one, it also capture the spatial information, X and Y coordination, as well as it will be contain the number of spectral band information also. So in a normal images, the RGB image contain only 3 bands, red, green, and blue. But in a multi-spectrum, we are going for the hyperspectrum images, and that one, the multiple band spectrums are there. Is ranges from the like 200 to the 1700 nanometers. So it's using to detect the biochemical changes before its visible symptoms appear. So it's widely used in agriculture for disease diagnosis and quality assessment. This one is the representation how the different spectral images are there. So there are the monochrome images is that it will contain only the black or white information is that. In the RGB images, there are 3 band spectrum is there, red, green, and blue. like red have a 630 nanometers spectrum is there. For the green it is a 545, and for the blue it is a 435. If we are going for the multi-spectrum images, it will be contain the number of wavelength data. So there are ranges from like 100 to 200 or 200 to 1500 nanometers contain data is there. Same way, if we are going for the hyperspectrum images, there are number of band spectrum data is there. So if you are increasing the number of bands, you can get the more information regarding the images. So if I'm going for the like hyperspectrum images, so if we're taking the normal visible vector spectrum bands like 400 to 700 nanometers, it will be used for the pigment sensitivity. So you can just identify the image, just use the RGB image, and you can easily identify the what is the disease that using the your eyes only. But if you want to find out the if the symptoms is appear in a low level, then you can have to just go for the multi-spectrum images. So if you are going for the near infrared, like it is used for the 700 to 100 nanometer, so in that one, it will be used to find out the water content and the soil structure. If we are going for the short wave infrared, like 1000 nanometer to the 2500 nanometers, so it will be used to find out the biochemical composition. And if we are using the number of bands which is available, if we have a different types of camera is there, using that one, you can find out the number of band spectrum data. So based on the band selection, you can reduce the computations and improve the accuracy. So after capturing the images, again, we have to select the which band will be give the effective data. So what are the challenges in the hyperspectrum data processing? So it will be, you have first challenge is the high computational cost, because it will be contain the number of multiple number of bands. So that's why its image size is too large. So for that is required a high computational cost. So second one is the model transferability issues caused by the environmental and variable differences, because there is a different environmental is that depend on that the image is also affected. So we go for this one is also one of the challenge of that one. Need for the standardization in data acquisition and the annotation. Okay, so if we are going for the like some of the cameras, they require the, some of the environment. So if you are going for the real-time environment, if they have a different acquisition scenario, and if you are going for the laboratory testing, that have a one different scenario. So in that cases, we require some standardization for the data acquisition. Then balancing spectral resolution with the acquisition speed for the field application. So in which speed we are taking the data, it is also affect, okay, how many days you are going to consider to taking the data. So that will be challenges of the in a hyperspectrum data processing. The literature view we have taken for the our paper review the research work. Like the first author we at al is use the pentagon detection in soil. So they use the methods like macroscopic and hyperspectrum images plus improved detection models. In that one, they have used of spectrum ranges from microscopic HSI, which is the very near infrared range likely, and they have find out the detection of microgorgon perminostica synodrops in a soil. This one is the one syndromes is there, which is available in your soil. So you can identify using the hyperspectrum images. They have some limitation. They just perform the lab-based testing. They have they require the validation for the field-based. The second author, Zhang et al., they have used this hyperspectrum multispectrum images for the diagnosis of the rise for the bacterial blight disease. In that one, they have used the machine learning algorithm to find out the how it will be identify the disease. Uh, they have identified the high multi-class diagnostic accuracy for the multiple rise pathogens. They have a limitation that require the field testing and cultivator generation, because they always whenever they're talking about the testing, they no go for the field basis. So this one is the main limitation regarding the each and every paper. The next author is also use the hyperspectrum images and the machine learning algorithm to find out the tomato bacterial leaf spot. They again use the hyperspectrum images, and they have focused on the symptomatic detection potential. Again, there is a limitation regarding the field transferability. The next author is UK et al. And they have used the again hyperspectrum means a machine learning based algorithm, and they have focused on the non-destructive detection of the nutrition content in sorghum. And for that, they have find out the accurate nutrition prediction model, but they have again limitation. The field-based sensor is untested. The Yunje et al. Is that next author is use the machine learning and result-based neural network. They have used this algorithm to predicting the quality of air-cured cigarette tobacco leaves, and they have find out the improved prediction using the region-based networks. But again, they have some limitations regarding the field variabilities. The Ozegon et al. They focus on the wheat kernel heterogeneous identification. They again use the hyperspectrum images and the machine learning algorithm and the deep learning algorithm. And they have focused on they have find out the SWIR outperform for the Vitreous classification. And again, that is a limitation to instrumentation cost because they require the hyperspectrum cameras. So for that, they require the high cost. If you require the more hyperspectrum images, to require the more data storage is required. Then again, the range selection for the consideration. For the in which range we can select the data, it will give the better output. Then the next author is Kim and J et al. They use the infrared VNR HS hyperspectrum images, and they have used the application to find out estimating the amount of soluble solid in a cytherea. They use the deep learning algorithm, and their findings are density reductions with the maintained accuracy. Their limitation, like the for the calibration and external validation, is required. Then the Jing et al. Author, they focus on the geographical origin discrimination of the wolfberries. They use the spectral imaginary feature fusion and the convolution neural network, and they have a focus on the hyperspectrum image. They find the like fusion improve the original classification, and the limitation is again like the full verification and broader geographic location, and cultivated validation is required. The next authors, Buan et al., they also focus on the identification of the rice seed backbenent pentagons, and they use the HSI and the deep transfer learning model to find out the disease in the rice seed. Rice seed. They find the rapid and accurate seed-borne
This is a
pentagon
gentle 9
identification.
minutes reminder.
Okay, thank you so much. So after that one, the proposed methodology is that in that one, the first acquisition of the infrared images is that hyperspectrum dataset is created using the hyperspectrum camera, and if it is another dataset is available in online mode also. Then they have I use the generative data augmentation with using the hard mixing and the soft mixing. After that, the whatever the data is augmented, after that one is provided to this for the segmentation. In that one, the global modulated depth separable location attention matter is used. After that, that will be provided to the feature extraction using the local triangular view binary pattern model. And after that, that will be provided the convolution neural network, which is the equivalent spatial pyramid convolution neural network. That one is used to find out the disease in your plant. Then the SAP is interpretatory kernel SAP is used for the interpretability of the result. The data set is used in that one. Apple tree plant is used for the disease. The disease is the like a have a three classes: water stress, incubators, and in a controlled environment. And they have a spectral band is around 1204 spectral bands. Different spectral band is used. They have a total sample of 512 images, and the data format is SDR and DAT format. In the generative data augmentation, they have that approach that combines the hard and soft mixing is used to improve the availabilities and get around the constraint of the dataset size. While the soft mixing selectively blends sections of the features, maintaining the significant class-specific properties, hard mixing entirely merge the spectral spatial data from two different samples to the construct a synthetic example. In a spectral spatial classification problem, it has been shown that this hybrid augmentation technique improves generalization performance, reduce overfitting, and straighten the model robustness. In a segmentation of approach, the global modulated depth separable location attention method is used. It is used to segment the areas affected by the infection. The use of Gabor filters, which are known for their capacity to identify the particular orientation and spatial frequencies. is used to draw attention to minute texture changes that may be sign of pentagon infection. And backed by separable convolution, it simplifies the computation without sacrificing the ability to extract the futures. By reducing the background interference, the location attention model helps the network concentrate on spatial regions of interest, increasing the segmentation accuracy. The feature extraction and classification. Discriminated features are extracted using the local triangular view binary pattern. The local binary pattern are effective for the capturing the microtextures and hues invariant movements encode the global safe information that is robust to rotation, scale, and translation. The triangular pattern variants further enhance the invariance and the texture discrimination by encoding pixel intensity relation in a non-linear triangular configuration. It's resulting in a compact yet highly descriptive feature set. In a classification with the equivalent spiral pyramid CNN, so in that one, the expected features are classified using the equivalence spatial pyramid convolutional neural network. The spatial pyramid architectures enables multi-scale features learning, allow the network to capture the both fine and coarse image details. The equivalence ensures that the model's output remain consistent under the geometric transformation
Excuse
and
me,
it
ma'am.
improve the
Uh,
reportness. Yes,
Sorry,
ma'am.
ma'am. I would like to request you to kindly conclude the presentation. You have crossed
Yes,
the
ma'am.
10 minutes mark well
Okay, okay.
before.
Okay, this one is like accuracy 97.8%. These are the experimental result of the our model. So I just conclude that one. The HSI combined with the deep learning enables precise diagnosis, disease diagnosis. Proposed framework is accurate, interpretable, and efficient. Equivalent CNN improves the robustness of transformation and suitable for the early crop decision detection in the agriculture. These are the references are there. Thank you.
Thank you, ma'am. Are there any questions?
Yeah, Bhavika, just can you tell me how does equivariant learning differs from traditional CNN-based approaches?
Sir, in that one, we are using the multiple layers are there for the convolution neural network, and they pass the data based on the some weightage model.
But have you compared results with CNN and equivalent variant
Yes,
CNN
sir.
models?
Yes, sir. It is in my journal paper. The all the comparison is there
Okay,
regarding
thank
the traditional CNN and the whatever the proposed methods is there.
you. Okay, thank you.
Thank you, sir.
Thank you, ma'am. Thank you, sir. Moving forward, I would like to request Sir Jay Bhutani to kindly present his paper titled Design and Implementation of IoT Inspired Smart Helmet for Accident Detection. Do we have you here with us, sir? Is anyone from the team present?
Yes, madam.
All right, just a second. Kindly share your screen.
Visible now? Well,
Yes, your screen is visible. You may start.
yes. Good morning, respected Chairman, Professor Amit Thakkar, respected faculty member, and my dear friends. I am a Jaipur Department of Electronic and Communication Engineering, CSQIT, Charleston. Today I am going to present our research paper titled Design and Implementation of IoT Inspired Smart Helmets for Accident Detection. This work is carried out along with my co-author Aryan Dubey, Arnav Das, Kilol Pandya, and Anil Pandya. This is the outline of my presentation. I will first discuss the problem in existing helmet safety system, then explain our proposed smart helmet solution, followed by hardware design, system methodology, prototype, result, and finally conclude. Introduction. Road accident, especially motorcycle accident, are a major safety issue worldwide. According to WHO, motorcyclists face a high risk of serious injury. In many cases, riders do not wear helmet, ride under the influence of alcohol, or emergency help does not reach them on time. So only wear a normal helmet is not enough. There is a need for smart helmet that can monitor rider safety automatically. Our solution is the smart IoT enable helmet that checks whether the helmet is worn, whether the ride has consumed alcohol, detect drowsiness and crash, and and control bike ignition accordingly. Problem in existing helmet safety. Existing helmet safety systems have several limitations. First, they do not verify whether the helmet is actually worn. Second, there is no mechanism to prevent drunk riding. Third, the bike ignition can be started even in unsafe condition. And finally, there is no automatic accident detection or alert system. So our main objective was design a low-cost, multiple functionality smart helmet that overcome all these problems. Proper solution for smart helmet system. To solve this issue, we designed an IoT smart helmet system. The helmet uses an IR sensor to detect whether the helmet is on, and MP3 alcohol sensor check alcohol present for rider breath, and MPU 6050 a sensor detect crash or fall condition. The bike ignition is enabled only when safety conditions are satisfied. Wireless communication between the helmet and bike is doing using RF module. If any unsafe condition is detected, then ignition relay immediately disable the engine. Hardware component. The major hardware component used in this system include Arduino microcontroller, IR sensor for helmet detection, MQ3 alcohol sensor, MPU 6050 accelerometer, and gyro sensor, RF transmitter and receiver modulation, ignition relay, and buzzer. Overall system level methodology. This slide shows the overall system methodology. The system is divided into two units. Transmitter unit mounted inside the helmet, receiver unit installed on the bike. The helmet continuously monitors the rider's condition based on sensor data are sent wirelessly to the bike unit. The bike ignition is performed only according to the helmet safety status. This is transmitter unit. The transmitter unit is placed inside the helmet. It reads data from the air sensor, MQ2 sensor, and MPU 6050. If any unsafe condition is detected, a buzzer alert is triggered for the rider. Control signals such as ignition on, ignition off, and crash alert are sent to the bike unit using RF communication. The receiver unit is installed on the bike. If receiver receives signal for the helmet unit based on the receiver data, the ignition relay is controlled in case of alcohol detection or helmet remove. The engine is remains off. Emergency or alert are also generated when required. Implementation slide shows the working prototype of our smart helmet system on the helmet side, IR sensor are placed inside the helmet padding. MQ3 sensor is placed near the mouth region. MPU 6050 is fixed on the inner line, and RF transmit send real-time data to the bike. The prototype demonstrates successfully integration of sensing, communication, and control. Control. Result and discussion. The system was tested under the different safety conditions. First, the bike did not start unless the helmet was on properly. Second, when alcohol was detected, the engine was blocked immediately, and buzzer alert was activated. Third, during the crash and fall detection, the system triggers emergency alerts successfully. Overall system show fast response time, reliable RF communication, stable performance during the real world testing. This proves the system is the practical and effective. Conclusion. To conclude, our smart helmet system ensures the helmets used before ignition, prevent driving, detect accident automatically, use low-cost hardware, and is scalable. This system has strong potential to reduce road accidents and save lives. The reference uses for the work are listed. Thank you, sir.
Thank you for your presentation. Yes, sir, please take forward the questions.
Yeah. So can you just tell me how does helmet orientation or central placements affects the detection accuracy in your case?
Helmet detection
Helmet
means
orientation and the placement of sensors affect your detection accuracy.
detection accuracy is 80 to 90%.
So will that helmet orientation change it? If I change the orientation of helmet, will it change the accuracy?
Yes, sir.
Okay. And which are the performance measures you have used to check the performance of your system?
Sorry, sir.
Have you used any other performance measures to assess the performance of your system?
No, sir.
Okay, thank you.
Thank you, sir. Moving forward, I request Ma'am Supriya Narad to kindly present her paper titled Disease Tracking Using Heat Map, a digital healthcare platform for local cities and prediction of diseases. Do we have you here with us, ma'am?
Yes, ma'am. Thank you for the opportunity.
Thank you for joining us, ma'am. Kindly share your screen.
Yeah. Ma'am, is the screen visible
Mm.
now?
Yes, ma'am, your screen is visible. Just put it in slideshow mode.
Yeah.
Yes, ma'am, your screen is visible. You may start.
Yeah, thank you. So, very good morning to one and all and the respected judges present over here. I am Ms. Supriya Narad and my co-author Anvish Takote. We are presenting paper ID 170. Title is Disease Tracking Using Heat Map, a digital healthcare platform for local cities and prediction of diseases. These are the contents. So as we are talking about disease tracking, so we have selected some areas in Maharashtra where we have to find out some diseases. And as we know that there is a rapid population in increase also, like in Maharashtra, I'm talking about the population which is going on increasing and increasing due to some companies or urban infrastructure, and there is a lack of reliable data on regional health trends, as it has made more difficult for local communities also to deal with disease outbreaks in recent years. So real-time location-based illness notifications that might assist individuals and health authorities in taking prompt preventive actions are frequently lacking from current healthcare systems. So suppose we are having such a healthcare system which may give you some assist for your health authorities, or they give some outbreaks also. So now that digital tools and public data are widely available nowadays, there is a chance to use technology to create intelligent systems that can monitor and forecast illness trends. Now, a complete digital healthcare platform designed especially for cities and local communities is also suggested in this article. So we have tried to cover such a platform where the local cities can get the messages, or they can get some digitally available data for their communities. Also, a symptom to illness prediction driven by machine learning is linked with a real-time disease heat map as part of the core functionality here. A naive Bayes classification classifier trained on a curated data set analyzes symptoms entered by users. So we have used our own data set for this region. Then simultaneously, the heat map uses geolocation data to show illness intensity by region also. So this data also we have accessed by using the geolocations of available persons, then search by region name, health data entry through a web or mobile interface, and the predictive feedback on possible illness risk are all made possible by the system. By bridging the gap between visual analytics and user contributed data, the system makes it possible to respond proactively to localized epidemics. It also functions as a prototype for upcoming systems in healthcare informatics that combine AI-driven illness surveillance with open geospatial technologies, etc. So this project not only helps for identifying the disease or illness, but it also finds out the intensity, as well as it will work like a surveillance. Now, a heat map interactive online map developed using leaflet .js and its heat layer plugin is included in the visualization and interaction layer. The map is populated with data from a CSV file containing geographic illness reports. So we have stored our data as a dataset in CSV file where the illness reports are available with geographic locations. Then the users can also perform a local search to get the latest information regarding the severity of reported diseases. We have used here HTML, CSS, and Bootstrap to develop the user interface, which includes search and marker functionalities. Now the bidirectional flow is facilitated by the entire setup, enabling users to gain insights as well as contribute the data. The system is compatible with installations at the municipal level, lightweight, and it is scalable also. The process that I am talking about is implemented as shown in this figure. So this is the process where the user is given at upper level. The user has to report the disease and the disease will be saved in the submissions.xls file. Then the user can be predicted like from which disease it is undergoing. So for prediction we are using here machine learning model and it is stored in pkp file also. We have to vectorize that data and predict by using the machine learning algorithm. Then we are using a heat map, that is a generated heat map which will show the locations on the Google map, that is it can be a geolocation. So we have to search the particular area by using the map, plus we have to find out the intensity of that disease also, that the disease is present, but what is the intensity, whether it can be again passed from one person to another. So that intensity also we have to find out, and again whatever the data is available that we will save in the heat map data as a CSV file. Now the system modular development process has steps like data preparation, model training, API design, and front-end integration. Now we are using the CSV file for data like words and matching illness classification is also stored there. Then count vectorizer was used to vectorize and pre-process the symptoms. Then we have trained the model like multinomial naive Bayes method was used to its effectiveness in text categorization. So it is again one of the machine learning method. Then SCA-KT-learn was used to train the model and JobLib was used to serialize it for use in real-time predictions. Then API design, we have used a Flask-based backend, that is app.py method that was created that includes routes for area-specific requests, data submission, prediction, and heat map data retrieval. Then Excel and CSV formats are used to provide data as a file or input. Then integration of front end. So for front end, real-time heat maps are displayed using the disease underscore map.html map interface, which retrieves data. Then users may check illness intensity and zoom in on specific locations like we zoom the Google Maps. So similarly, we are providing this facility here also. The user interface for browsing between modules is included into the site, that is index.html. Then modularity, quick deployment, and simplicity of future growth are guaranteed by the technique. Additionally, it highlights community involvement via local relevance and user-friendly designs. So as per the results and analysis, we evaluated this on synthetic data. So one data set that we have created, another data set that is available as a synthetic data. The prototype system consistently produced results in terms of heat map rendering and classification accuracy. Now, because of the distinct symptom classification, the new Bayes model showed appropriate symptom disease mapping despite being trained on a tiny data set also. The intensity hotspots were efficiently presented using the heatmap component, which operated more smoothly in most popular browsers. Zooming into impacted areas was made easier by real-time area search, which was improved usability. On local servers, the architecture performed with low latency and every part worked together well. So this disease map is shown in this diagram. So this is the disease map, the deployment we have done in Nagpur city. Now you can see various areas of Nagpur city also, like Kasturchand Park, Sitabardi, then Baidyanath Square, then other squares like Gandhi Bagh also we have highlighted here. So a disease surveillance system prototype deployment was simulated for Nagpur, Maharashtra. Then 5 well-known communities were selected like Mangalwari, then Hanuman Nagar, Sadar, Dharampet, and Sitabardi. Synthetic data was selected for common diseases such as flu, dengue, and malaria. So we have identified these diseases in that area if present. Then users began using the web app in Sitabaldi to upload symptom data. After processing the data, the backend predicted a cluster of dengue cases. The heat map was used to visualize a hotspot over a period of 7 days. Simultaneously, the local authority used the information to provide advice for controlling mosquitoes in that impacted regions also. So like we are not only identifying the disease, but we are providing some advices also to the authority, local authority or governance we can say. The website effectively demonstrated its capacity to track the onset of outbreaks. Then it map out specific regions and engage the public also. The disease map is shown in the figure that just I have discussed here. So this is the disease map where we have finded out the particular areas as well as the disease. Then high intensity zones are marked in red mark, then moderate in orange or yellow, and low in
This
green.
is a
So these
gentle
three
9 minutes
colors,
reminder.
yeah. So these three colors we have used to highlight. Then users can zoom into specific regions or pan across different districts or states. This provides localized insights and encourages users to explore disease trends in neighboring area also. Then there are some applications of this disease tracking like AI-driven application, symptom prediction model, real-time geographic visualization, crowdsourced surveillance. So it is, I think, one of the best application. Then area-based search and analysis, automated alert system, as well as healthcare resource planning. Then conclusion, I'm concluding here like the digital platform that is being presented shows how well machine learning and geographic visualizations can be used to monitor and forecast illness in urban settings. Then the platform connects data-driven decision making with public engagement by allowing users to contribute and obtain health information in real time. Heat maps combined with symptoms-based forecast enable individuals, local governments, and health organizations to better comprehend and address the localized epidemics also. The system is extremely extendable and acts as a prototype for more sophisticated intelligent systems, as well as in a time when technology and data may transform healthcare delivery at the local level. The project emphasizes the value of decentralized, transparent, and interactive public health solutions. So these are the references that we have used for development of this project. Thank you very much for this opportunity. Thank you.
Yes, ma'am. Can you tell me, can we use some advanced explainable AI techniques to replace heat map for better understanding and visualization of this? If yes, then what could be that technique?
Yes, sir, we can use because, sir, right now what we have used that is the machine learning algorithm. But if we are using explainable AI, then that will be better. If we are using decision trees, sir, then decision tree algorithm can also be used here because in decision tree we can again map the locations properly. That is again one of the method given in ML. So there are multiple algorithms available that you can use as per you want to make efficient the project. Okay, so I think that all the methods are available, and we have to find out accuracy for individual method also because it will be based upon accuracy that which algorithm is giving us more accuracy.
Okay, thank
Yeah.
you.
Thank you, sir.
Hello. Thank you. Thank you, ma'am.
Thank you, ma'am.
Moving forward, I would request Ma'am Khushi Nagraj to kindly present her paper titled uh, Document Image Analysis, a review of existing approaches and future scope. Do we have you here with us, ma'am?
Yes, ma'am, I'm present.
Okay. You may share your screen.
Yes, 1 minute. Yes, is it visible?
Yes, ma'am, it's visible. You may start.
Okay. Hello, everyone. I'm Khushi Nagraj, and I'll be presenting the paper that I wrote with my teammates under the guidance of our associate professor, Sunil sir. Today, I'll walk you through a review of document image analysis, basically the survey of existing approaches, their limitations, and practical future directions. And I'll also show you how these ideas map to a prototype that we've developed for intelligent document parsing. So, this is my agenda for the talk. I'll begin with a short introduction and the motivation behind document image analysis. Then I'll summarize the abstract and move on to the central problem statement, We'll move on to the literature survey highlights, and I'll point out the limitations in our current system. Finally, I'll conclude with the references. Now, to begin with, an introduction to the entire domain. Document image analysis, or DIA, matters because a huge volume of our knowledge exists only as scanned documents or PDFs. For example, invoices, medical forms, research articles, contracts, etc. Manual extraction of data and information from these documents is very slow and error prone. So, automating this entire pipeline from image to structured data, it unlocks faster decisions, better analytics, and eventually makes up for lower costs. But the challenge for this is that documents vary a lot in layout, in language, in quality, etc. We have various different types of templates for every sort of document, where medical documents are follow a separate template than, say, email related documents. So the core question will be, how do we build systems that are accurate, robust, and auditable across diverse fields, across real world documents? That's the central motivation of this, for which we surveyed papers and for our own project. Now, the abstract of this paper, in short, the survey traces DIA's evolution from rule-based heuristics to modern multimodal deep learning architectures. It reviews pre-processing and segmentation techniques, large layout data sets like PubLayNet and DocLayNet, RANLayNet, etc., fusion models, and end-to-end vision language systems, and places special emphasis on cross-domain transfer and scalable annotation. The survey's main message is that hybrid approaches, which combine deterministic OCR and layout processing with multimodal LLMs, plus verification and some sort of checking, they are the most promising path forward. Now, let me be precise about what the problem exactly we're addressing. Automatically extracting structured fields from documents, for instance, let's say invoice numbers, vendor names, dates, line items, total prices, etc., if we take the example of an invoice, automatically extracting these fields from heterogeneous scanned documents remains hard because of layout diversity, where many column specific scientific papers, vertical forms, invoices, etc., they all follow very different layouts. Image issues. When we scan documents in the real world, there'll be skews, there'll be blurs, noise, the colors might be different, the resolution might be low, etc. The semantic needs of the output. The information that we wish to extract from a medical document will be different from the information that we wish to extract from, say, a contract. So what the output needs to be and how this output needs to differ based on what document it is, that is also an issue that we need to address. And rule-based brittleness. So heuristic methods such as OCR often fail on new and unseen templates, any sort of document that it hasn't seen before, etc. So our objective is basically to build a robust pipeline that can segment layouts, run accurate OCR, extract semantic fields, and adapt to new templates without any effort, and represent this final output in, say, a JSON format or an XML format, or even in the format of a data set. Now we'll move on to the literature survey. So to summarize the literature survey, the earliest document image analysis methods relied heavily on image preprocessing, thresholding, morphological filtering, and connected component analysis. These techniques are still important because they provide a lot of efficient pre-processing like binarization, denoising, and segmentation. But classical classifiers and handcrafted features were used for layout and character recognition before deep learning. So the final takeaway from the LIT survey, which we will get through, is that pre-processing remains a very necessary first step, even in modern pipelines, because it conditions the input for downstream algorithms. So one of the first papers was document image analysis, a primer, which basically defines core DIA tasks: pre-processing, layout analysis, OCR, and graphics recognition. Now, this forms the very basis of document image analysis, almost all the systems that we come across today, where the first process would be to clean the image to remove all skew, noise, etc. The second will be layout analysis, understand which part makes up the heading, which part makes up the columns, which part makes up the textual information, which ones are images, etc. Then applying OCR for the relevant sections, extracting the text from wherever we need, and finally the graphics recognition from where we need. So this is the typical workflow given in this paper: capture the data, binarize the image, segment the image, and then recognize the text and everything, and finally interpret the document. We move on to slightly modern methods using artificial neural networks in the next paper, where these applications span OCR, layout analysis, segmentation, and word and signature recognition. Now, this survey it basically presents a unified framework for DIA methods. It emphasizes the role of prior knowledge in architecture and learning. Then we move on to a little bit more of camera-based document image analysis. So this paper specifically deals with how to process camera-based images. So it talks about blur, perspective, lighting, and how to compensate for all of these, etc. We then move on to a few papers which talk about specific architectures for document image analysis. PPV Structure V2 provides a very comprehensive framework for an architecture for this specific need. One more aspect we looked at was explainable AI for document image analysis. Since a lot of LLMs and everything have come up right now with transformer architectures, the problem with all of these is the explainability part, where we will not know what is going on with the entire deep learning architecture. And we were looking at basically how to present an explainable aspect for this. So how to basically show what the AI is doing behind the scenes. And for that, we went through a few papers specifically related to legal document review and explainable AI in that. Finally, we went through a few data sets related to document image analysis. So PubliNet is a data set with over 360,000 annotated pages. It consists of papers divided into 5 classes: text, title, list, figure, and tables. And this data set has proven effective for very fast learning for various models. DocLayNet is another extension of PubliNet with 11 classes for different sorts of documents. It includes very diverse sources. PubliNet only includes medical documents and scientific papers, but DocLayNet includes very diverse sources. There are reports, manuals, invoices, forms, etc. A few other data sets were RanLayNet, which was a synthetic data set that was built on PubliNet, and it consists of 5 core classes, same as PubliNet, but it's a synthetic data set, so takes up a lot less manual effort. And we went through a few other layouts and architectures for this particular thing, such as VT layout, which is a fusion of visual and text features.
This is a
and
gentle
provides
9 minutes reminder.
Yes, okay. Now moving on, here we find out why after the survey of this entire thing, we find out what are the limitations of our existing systems. The main limitations that we have found, one is adaptability, where if in case we bring in a new template to the model will basically break on these unseen templates and formats. Transparency. Now, this is the part about explainable AI. All the decisions are black box decisions made by specially deep learning models, where we will not know how the model arrived at a conclusion. And structural semantics, relationships, for example, item to line to price relationships are not always modeled correctly. And finally, the cost of data. So the annotation cost is basically the cost of bringing together a data set that our model can train on. High quality labels and for complex layouts are very expensive. Addressing these limitations basically motivates hybrid verifiable pipelines and active learning strategies. Coming to the societal benefits of DIA, when DIA works well, the benefits are widespread.
I'd like to request you to kindly conclude, as you have crossed the 10-minute mark.
Yeah, okay. So it works well in various fields. You can use it in medical fields, in all sorts of contractual documentation fields, legal, etc. And these were the references that we've used. Yeah, thank you.
Thank you, ma'am. Can you just give some spot on which evaluation matrices are suitable for assessing document image analysis systems?
The document analysis method we were using, suppose we use a particular data set in order to train the documents, any sort of accuracy metrics to see at what level of confidence it's predicting the layout parsing, any sort of accuracy metrics will be useful for this.
And any specific challenges you come across for multilingual data sets or documents?
Yes, so multilingual data sets, the main problem is getting data sets to train on. The main language that we've seen is English, and getting documents and enough documents for training the models on various languages is very, very difficult because it takes a lot of manual effort to get documents in different languages and also annotate it and then train the model.
Okay, thank you.
Thank you.
Thank you, ma'am. Thank you, sir. Moving forward, I would like to request Ma'am T.A. Akshaya to kindly present a paper titled Green Startups and the Triple Bottom Line: Economic, Social and Environmental Pathways to Sustainable Development. Do we have you here with us, ma'am?
Am I audible?
Yes, you're audible. Yes, you can share your screen now.
Okay. Good morning. Myself, Akshay. I am from ASB Coimbatore, and my research guide is Dr. Suresh from the Amanda School of Business, Coimbatore. And this is my paper, the paper ID 197, Green Startup and the Triple Bottom Line, Economic, Social and Environmental Pathways for Sustainable Development. And this is the outline of this presentation. And we are discussing about the green startup and its contribution to sustainable development goals through the TBL framework, triple bottom line framework. Triple bottom line framework is actually evaluating the contributions towards the sustainable practices while we are analyzing the green startups contribution to sustainable development goals. As we know that startups are the emerging new firms that we are focusing on rapid and technological integration in their business models. And when we come to the sustainability, there are three pillars in the sustainable development goals, that is social, economic, and environmental. And they are more focusing on the sustainability than the profit or economic intentions. And, attaining sustainability through green when it comes to the green sustainability, it's a major challenges faced by the business models in the existing system. So the green startups are more focusing on addressing these environmental challenges. So green startup has a central role in sustainability transition, and they are focusing on low carbon future, addressing environmental challenges, and diffusion of green technologies. So basically, green startups are the firms. They have so much definitions about green startup. Basically, they are the new emerging young firms. They are mainly focusing on the rapid expansion and the technological integration into the business models. When it comes to the green startup, they are major focus on the ecological sustainability. They are considering the heart of their business models. So the green startup just not a business, they are the potential leaders for the sustainable development goals. They are balancing the economic growth without harming the environmental sustainability. So they are focusing on introducing innovative solution for balancing economic growth as well as the environmental sustainability. And this why this study matters, because these green startups addressing the environmental challenges, they are mitigating the environmental problems and be providing environmentally beneficial product and services. So they support a sustainable development, and they also integrating sustainability dimensions while we are analyzing through the triple bottom line framework. The economic, environmental, social dimensions were integrated in the green startups, and the existing stock of research were not addressed at the young firms, that is green startups, to triple bottom line framework. Then the studies were conducted in the manner of qualitative and mixed method. There is no studies on the conceptual with linking green startup and triple bottom lines framework. And this study contributing to the existing stock of knowledge through addressing triple bottom lines contributions to green startups. And it's also incorporating the social, economic, and environmental dimensions. So the social dimensions, while how the stakeholders and their objectives towards attaining the sustainability goals through the green startup is addressing here, and also providing policy insight to the environmentalists or the policy makers to how they can integrate the environmental policy to attain sustainable development goals through promoting the green startups. And this is the research question of this study. How do green startup contribute to sustainability through the social, economic, and environmental dimensions? And here we are used the research methodology called PRISMA, that is preferred reporting items for systematic reviews and meta-analysis. There are four steps in this methodology. First one is identification, through which we identify the literature. The first initial stage we founded for 59 literatures relating to this study, and the initial screening we found 59 itself, and the eligibility through excluding publication type and duplicates, we found 49 literatures. And while excluding these, we addressed 49 literature for this study. And the results came into the three dimensions: social, environmental, and economic dimensions. For social dimensions, how this green startup is influencing in the society perspective. Ecosystem influence, that is green startups. We know that green startups are the firms, they have the influence from the social factors also. So the green entrepreneurship, they are the emerging, they are socially rooted. So the physical, societal, and heritage-based factors influenced to the green startups. And the stakeholder engagement, which we know that the founders are the key role playing in the business model. So they are the potential leaders through the how they can integrate their business models into the social, environmental, sustainability factors, and their shared responsibility is very important in this field. And regional upliftment, the startups or any business is providing a support for the regional upliftment. Through the green startup, we are addressing the green development in the areas as well as the environmental sustainability in the models. And employment and equality, business can provide, or the startups or entrepreneurship can provide employment opportunity as well as they can even reduce the inequality existing in the communities. So these green startups, along with the reducing inequality and also providing providing job opportunity, they are also addressing the environmental sustainability. And in these days, the youth and women entrepreneurs are coming into the field of business. So the universities and the government should support them for the for entering into the business green startups, so they can through they can promote social inclusion as well as more employment opportunities. And green startup is considered as an agent of change because startups integrating technical skill and technological knowledge, they are very flexible, they are not resistant to the change, so they can be considered as an agent of change. And these are the contribution of green startups through the social dimensions. When it comes to the environmental dimensions, they are addressing the global challenges, like majorly the economic challenges, environmental challenges, and social challenges. When it comes to the environmental challenges, the global warming, carbon emission, net zero goals, they are addressing. And the ecological innovation, they are creating new inventions in the field of designing, production, and distribution of environment sustainable methods. And they are also practicing waste management, how they can efficiently manage the waste and how they can incorporate circular economy practices in their business. And they are also contributing to the pollution control and promote cleaner environment. And they also integrating green technologies and making collaboration with the other firms. They are promoting the green innovation, and they support digitalization, decarbonization projects, and in investing in the field of monitoring technologies and carbon emission also. And through the environmental policies and the international environmental support, they can incorporate their more open innovation into their business field, and environmental policies have a huge impact in the development of green startups. And when it comes to the economic dimensions, finance and government support is necessary for the upliftment of green startups. So they can, according to the data of Camus cited, the 1 point increase in the funding leads to 12.6 rise in the ecological innovation activities in the green startup. And the investment should be channelized. The international organization should focus on the environment sustainability investment. They can uplift the green startups innovations, inventions, and their activities towards the sustainable development goals. And strategic green investment. These investments should be in the key area and the strategic area to the upliftment of green startup through to the environmental sustainability. And venture capital and global expansion. We
This
know
is
that
Jane
venture
till
capital
9
is an
minutes
important.
reminder.
Okay, thank you, ma'am. Venture capital is an important matter for the development of green startup and open innovation and firm growth, like university startup incubation firms and customer support is necessary for the development. And they are also green startup facing financial challenges and market challenges, like leading financial difficulties on relying external funding, R&D development. And these are the result of my study, and the scope for the research is we can analyze further research should analyze the applicability and sustainability of green startup through triple bottom line, and there is no prior studies on cross-sectional analysis and longitudinal studies. And the implication in this study is the application of triple bottom line framework in the young firms in the environmental sustainability concerns, and the practical implication for the entrepreneurs. They can build strategies for conducting sustainable business by balancing the people, planet, and profit. For the policymakers, the government and educational institutions and the financial institutions should focus on the development of green startups. And these are my limitations of my study. This study is only documented the papers indexed in the Scopus database up to the to August 2025, and this study is based on the secondary data, so the generalizability is limited. And these are the references of my study, and this conclusion is like green startups have a high driving power to the sustainability. So if we are more focusing on these kind of startups for the achieving sustainable development goals. So thank you, sir.
Okay, thank you. Can you just tell me what economic challenges do green startup face in the early growth stages?
So the basic challenges is the finance they're getting is limited. So they are mainly focusing on technological upliftment. So the finance needed for the development of green startup is necessary. So the government should support for the green startup to engage their business.
How do we attract the investors for these green startups?
Sorry, sir.
How do we attract the investors for the green startups?
Through the major advantage of green startups, they are focusing on sustainable development goals. So the environmental sustainability, that is the globally we are focusing on moving towards these sustainable development goals. So new innovations and inventions can be attract more investment in the green startups.
Okay, thank you.
Thank you, sir.
Thank you so much, ma'am. Thank you, sir. Moving forward, I would like to invite Ma'am Asta Bhimani to kindly present a paper titled Heart Attack Risk Prediction Using Logistic Regression and Risk Factor Modeling. Do we have you here with us, ma'am?
Yes.
Yes, you may share your screen.
Yeah, just a second.
Mhm.
Is my screen visible?
Yes, ma'am, your screen is visible. You may start.
Good morning, everyone. I'm Asta Bhimani, a postgraduate student of statistics from Christ University, Bangalore. And today I will be presenting my research paper on heart attack risk prediction using logistic regression and risk factor modeling. Heart attacks are no longer a problem limited to older adults. In recent years, there have been a noticeable rise in cases among younger individuals, often without obvious warning signs. This highlights the importance of early risk identification, not only for treatment, but also for prevention and timely intervention. So, this concern forms the motivation behind my study. Can we use routinely available clinical data to estimate an individual's heart attack risk in a simple way? So, like I said, it remains a major global health concern and global mortality. Lifestyle changes such as physical inactivity, stress, and unhealthy diets have increased vulnerability even among younger adults. Traditional diagnostic methods are often invasive, time consuming, or applied only after symptoms become severe. As a result, they are not ideal for large scale screening or early detection. This is where data driven models become useful. Among machine learning techniques, logistic regression stands out in healthcare because it's both effective and interpretable. In this study, I have used the UCI heart disease dataset, which contains commonly measured clinical attributes and is widely used as a benchmark in heart disease prediction research. Um, Yeah, so for my literature review, the key findings were most studies using logistic regression report accuracies in the range from 80 to 86%, demonstrating reliable performance. Commonly used data sets include UCI heart disease and the Framingham data sets, both well established in cardiovascular research. Key predictors repeatedly identified across studies include age, cholesterol levels, chest pain type, exercise-induced angina, old peak, and thalassemia. While some studies explore advanced or hybrid models such as random forests or LRSVM combinations, these often achieve slightly higher accuracy at the cost of reduced transparency. Importantly, the majority of existing models focused on binary classification. So, this led to a clear research gap. Most current heart disease prediction models produced only binary outputs, and they relied on raw clinical values that vary widely in scale, and they did not generate continuous patient-specific risk scores. Um, so, in my study, to address this problem, I proposed a logistic regression-based framework. The model computes a weighted linear combination of clinical features where each weight reflects the importance of the specific risk factor. This linear combination is passed through a sigmoid function to estimate the probability of heart attack occurrence. Thus, the model not only predicts risk but also explains why a patient is classified as high or low risk. A key contribution of this work was the use of the min-max feature scaling. So, continuous variables such as blood pressure, cholesterol, and heart rate were all normalized on a 1 to 5 scale. So, this ensured balanced contribution of all the variables, and it improved interpretability, and it aligned naturally with clinical risk categories. Binary variables were not scaled to preserve their original meaning. So then the continuous probability output from logistic regression was mapped to 5 discrete risk levels. Level 1 represents low risk, while level 5 represented very high risk. Um, so this is just an example of patient 1 with all of this data to explain how actually this is being implemented. So the patient's categorical variables are first converted into numerical values, and continuous features are normalized to the 1.5 scale, which can be seen here. And then these values were substituted into the logistic regression equation. So the calculated heart attack risk factor for this patient was approximately 0.379. So we can say that this patient had a moderate risk of heart disease based on risk level 2, corresponding to risk level 2. So initially we generated a heat map for correlation analysis, which gave us the variables which were most important and which contributed significantly to the heart attack risk. The model was evaluated using standard matrices. So we got an accuracy of 80%, a recall of nearly 89%, and an AUC of approximately 79%. So this is the confusion matrix that we got with the true negatives, false, and the true positives. And in addition to accuracy and recall, the model was evaluated using the ROC curve as well, which illustrated the trade-off between the sensitivity and the specificity across different probability thresholds. So the ROC curve plotted the true positive rate against the the false positive rate, allowing us to assess how well the model distinguished between patients with and without heart disease. And the AUC curve, the area under the curve, it is approximately 79%, indicating good discriminative ability. So this meant that the model can reliably separate high-risk patients from low-risk patients. In conclusion, this study proposes a logistic regression model, heart attack risk prediction model that produces continuous and patient-specific risk scores. It stratifies patients into 5 interpretable risk levels and balances predictive performance with transparency. So this model is computationally efficient and suitable for integration into electronic health records or mobile health applications, etc. Thank you.
Can you tell me why was the logistic regression was chosen for a prediction of heart disease?
So logistic regression model is like has a clearer meaning, and it allows like, it's more interpretable and it's more usable when it comes to healthcare records. And it provides probability based outputs also that is directly quantifying the contribution of each particular factor.
Have you compared your result with any other model to just make sure that regression model performs better than other models?
No, sir.
Okay. Thank you.
Thank you.
Thank you, ma'am. Thank you, sir. Moving forward, I would like to request Sir Neerav Patel to kindly present his paper titled Innovative Approaches to Structural Health Monitoring and Their Role in Infrastructure Protection. Do we have you here with us, sir?
Yes, I'm here. 1 minute.
Yes, your screen is visible now. You may start.
Okay, so good morning again. So now I'm audible?
Yes, sir, you're audible.
Okay. So this is one of the topic of my research scholar, what we are doing in heritage monitoring. So this is the one what we can say basic study, introductory study of innovative approach in structural health monitoring and their role for different infrastructure projects. Okay, so why this matters? So structural health monitoring gives us these 6 benefits. First is early damage detection, through the which we can identify how we can go to the damage control, then reduce the risk failure, prediction of maintenance, what kind of maintenance we can adopt, lower the life cycle costs. So we can what we can say minimize the maintenance, so life cycle will be increasing and the cost is reducing. Broad applicability is there and benefit for all the ages. All the ages means all the types of structure, whether it is newly constructed, old construction, and as I said, heritage construction. Okay, so what are the basic objective of this structural health monitoring? That is, it is detect the defects at very early ages and also reduce the downtime of that progression of that defect. Now, minor structures monitor of structural performance over and over time and inform the prevention of maintenance and decisions. Okay, there are 2 types of SHM, that is active and passive. Active is we can say directly we can collect the data from the signal, measure the response from the whatever the sensor we have integrated into the structure or any material, and typical output from model frequency to the damage design. Passive means we can transfer whatever the data collected by that direct method and we will predict from our side, like the use of ambient excitation like traffic and wind, infer the changes in frequency and damping, then typical output for mode shape and long-term trends. These are the related to earthquake and what we can say lateral movement for the any structures. Now, what are the new implementation we are doing? That is nowadays the AI and machine learning are what we can say boom in the market, or boom that technology that we have to embed it in every field of the work. So machine learning and AI, how we can implement in structural health monitoring, that are the three steps are there, that supervise, that SVM, structural valuable monitoring, neural networks are there. Then unsupervised, which is autonomous are there. So detect unknown faults, and deep learning. So we can introduce the deep learning also. So which we can say data collections are there, and that we can collect the various data and predict that them also in future forecasts. What are the benefit to earlier detection, as I did, and reduce the human reviews. So every time that we require expert things, or in building or infrastructure way, if I talk, that is a one building is constructed and building is last for the 100 years, so we don't know about its previous history also, because that man who has or people who has constructed it, what they are people are using it, and at the time of some restoration required, then that those people are different, so we don't have that much amount of data previously. But if integrated this machine learning, AI, deep learning, or data storage, we can do that thing in future also. These are structural health monitoring in civil aspect. So civil aspect, which we have seen that major requirement, or major what we can say implementation, what we require in a multi-purpose structure like bridge, high-rise building, tunnels, railways, dams. So how we can monitor them? So bridge we can monitor, we require for displacement, strain, vibration, temperature fluctuation. What are the method we can use? The method are listed, and where they have used. So Singla bridge are there, where they have used thermal and load sensors. Then for high-rise building, Burj Khalifa, we all know that will sustain for the high pressure wind and earthquake, and thermal changes are there over there. Uh, Tunnel and railways. So in tunnel and railways also displacement, temperature are required. Dams dams are most critical structure if I talk about from structural point of view. So in that also hydraulic response and hydraulic movement are required for to measure this to requirement for the structural health monitoring systems. Okay, there are benefits are listed. So benefit we have already I have already implements that there are completely mainly for safety purpose, then maintenance purpose, and then reduce the cost of the long term infrastructure maintenance. Then apart from civil, we can utilize this health monitoring for aerospace and marine application also. So for aerospace, onboard structural health monitoring composite, for airframes, especially because airframes are also made up of some joints, and whatever we do in structure, the same phenomena we have to utilize, they utilize for the aerospace. Then sensors and metrics, then marine and offshore, which is robust in structural health monitoring for the harsh environment. Marine environment is very harsh because of saline and everything. They have fatigue in nature, corrosion in nature. There are previous simultaneous changing in the load because of the water pressure. Then marine sensor and its metrics. So use acoustic. We require acoustic. Fiber optic sensors are there. All our fibers and data connections are going from the seabeds. Okay. What are the outcomes? So reduce the downtime and failure prevention, because these two things are there which will be beyond our visibility and touch. Aerospace is outside the or completely above the earth surface, and marine is completely below the earth layer. So this two is very challenging nowadays. So structural health monitoring and this kind of sensor which will help us to create proper planning, maintenance, and detection of any failure. Now industry and heritage monitoring, what we are doing in this in our research, this is what we are going for this thing. So industry, so wind turbines are there, which has continuous moving elements, so strain and vibrations are there. Because of their height also movement is more there. Rotating machines are there, so reduce the unplanned downtime and targeted repair and longer lifespan we can achieve here. Heritage, so all are, as I told you earlier, that all our heritage buildings are more than 1,000 or 800 years old. So we don't know right now what are there that going inside that. So we can the environmental change and their loan monitoring, defects, everything. So targeted conservation, what will the method we can use, what are the chemical is going to use or not, that we can easily check here. And what is the value that we can preserve the our historic integrity. The example, the Colosseum Museum is there. Even our Taj Mahal is a very good example, because continuously we are going to implement this kind of maintenance or retrofit, we can say that. And that thing, that monitoring or structural health monitoring point, which will be very useful and utilization for this kind of implementation. Now, major challenging is there, because of it is high installation and maintenance cost. Initial maintenance cost is very high because of sensor. How we can implement, that is also skill labor required, and very skilled person need to require that. What are the point that we have to implement, what kind of process, data overlay across the
This is
system.
a gentle 9 minutes reminder.
Okay. Then environmental effect on the sensor, because sensor is again vulnerable to the environment. So if some environment temperature is increasing or so sensor are what we can say damage is there or not in sensor. So we have to create sensor such a way. Adoption of some certain constraint for smaller organization. So smaller organization, again we require smaller scale or some smaller amount of what we can say entrepreneurship or startup program for this kind of things. That is also challenging. Now what are the best practice? So best practice is above adopt wireless sensor, which is nowadays very easily available and cheap in rate. AI driven, so AI integration, that also one kind of suggestion we can adopt, or research area. Design the robust sensor on board or house on house calibration, if we can do. Implementation of edge processing and selective data transfer. Now, what is the autonomous or SHM? So self-healing network, that also we can have one kind of uh, future aspects. Then nanotechnology in sensor. So nanotechnology also we can use, because of this if we require small amount of sensor inserted in some very minor portion in infrastructure. Nowadays this we can use for the health point of view, we have started, but in structural or some critical part we can develop. And lastly, the conclusion of this point, that SHM is essential for safer and longer lived infrastructure, balance trade-off, sensitive and various cost, plan data lifecycle, data needs processing and storage, and prioritize integrated stable system and maintenance. And next is to integrate with its IoT integration and AI trials, some sensors. Thank you.
Thank you for the presentation. Mr. Niro, can you tell me what performance matrices are used to evaluate the structural health monitoring system?
So such a it is basically some for different purpose we have different matrices. For basically, if we talk about structural point of view, right now we are using IoT based application, especially if we talk about smart sensor, smart technology which can detect the strength of the material, which can detect the vibration of the building, even we can say strain check. So, and in heritage, if you talk about right now, what we are doing is in heritage, we are checking first of all what are the chemical composition is changing. After that, only we can suggest that okay, which kind of treatment we need to go.
Okay, thank you.
Welcome.
Thank you, sir. Moving forward, I would like to request Sir Kabir Mota to kindly present his paper titled Juris AI IPC Section Detection System. Do we have you here with us, sir?
Yes, I am available.
Okay. Please share your screen.
Yes, just a minute.
Yes,
Okay, so it's visible, right?
Yes, your screen is visible. You may start.
Okay, so myself, Kabir Mota, I am alongside my co-author Manav Sapode, and we are here to present our paper titled Judiciary IPC Section Detection System. So this is the outline of our presentation. So introduction. So why do we exactly need an IPC section detection system? So basically the FIR filling requires legal knowledge. General public struggles to identify correct IPC sections. FIRs are written currently in unstructured and informal language. Manual IPC section detection takes a lot of time and which thus, thus results in high chances of human errors in legal classification. So the main motivation was to overcome the above discussed problems and the problems like incorrect IPC section detection, delays in FIR processing, dependency on legal experts, and to address the growing need for more accessible legal support. So Juris AI is an AI-powered system that analyzes FIR text and predicts relevant IPC sections, thus simplifying FIR drafting and making legal knowledge accessible to everyone, citizens as well as law enforcement agents. So the primary objective was to develop an reliable and intelligent system capable of automatically analyzing the narrative text found in FIRs, predict relevant IPC sections accurately, reduce manual legal dependency, and assist police as well as citizens during FIR fillings. So to achieve this, the project aimed to create a high-quality structured dataset and generate realistic synthetic FIRs using NLP techniques to robustly train a predictive model. So this is the literature survey which we took in place. So the first one is Decision Support System for Automated IPC Section by Ambrish Srivastav. So it focuses on IPC section identification to reduce manual effort and improve legal classification accuracy. But the main problem was it uses basic similarity based methods as semantic analysis, whereas we are using advanced ML models and confidence scoring in our jury AI system. The next is fast text XGB, which is a hybrid machine learning approach for predicting IPC sections. It uses ML to improve efficiency, but it relies only on fast text XGB boost, which does not include any synthetic FIR generation or detailed legal explanations, which is covered by our system Juris AI. The next is ML approaches for IPC section by Prakash Aryan. It emphasizes ML for high accuracy, but it focuses mainly on SVM and lacks multi-level handling, confidence scores, and explainability mechanisms. And the last one is dynamic multitask learning for minimal supervision in automatic charge identification by Shaunak Paul, A. Anand, and P. Chaudhary. The main aim was to address the data scarcity challenges, which is covered in Juris AI, but it uses complex multitask learning models, which is less practical in real-time FIR fillings, whereas Juris AI's simpler ML pipeline is more reliable in real-time FIR filing cases. So this is our proposed solution. So the proposed architecture consists of 5-stage pipeline. The first stage is data collection, which is gathering of real FIR cases available with IPC sections. The next one is data pre-processing, which includes the stages like cleaning, tokenizing, lemmatization, and stemming. The next is converting the text into numerical data using TF-IDF, which is known as feature extraction. And the fourth step was one of the crucial step was generation of realistic synthetic data set. So the main cause of generating synthetic data set was first that the real FIR complaints are not much accessible online. And the second one, the available FIR complaints were imbalanced towards a few of the IPC sections and not all IPC sections were covered. So generation of synthetic data set covering all the IPC sections was a necessary step for our model training and evaluation. And the last step is model training, for which we used and compared 4 different ML algorithms, which were SVM, naive Bayes, random forest, and logistic regression, out of which random forest performed the best with an accuracy of 87%. So this is our system design. So system architecture consists of three parts: front end, back end, and database. For front end, we are using React.js. For back end, we are using Python-based server for NLP processing and IPC prediction. And for database, we are using SQL for storing the FIR data as well as the prediction results. And our architecture consists of three layers: user interface layer, business layer, and data management layer. So user interface layer consists of FIR submission and IPC result visualization. Business logic layer consists of text pre-processing, feature extraction, and IPC section prediction. And data management layer consists of storage and retrieval of FIR records. So this is how our algorithm workflow happens. So the user has an option to provide input in two ways, either text input or the voice input, which is forwarded to pre-processing layer of NLP model. The user authentication takes place using three approaches. They can be verified using Aadhaar authentication, email OTP login, or input validations. And further, the input is passed to our AI processing and analysis layer where FIR categorization happens, IPC section detection happens, crime type prediction happens, and the final output is given to the users. So these are the system outcomes where we can see login and sign up pages, the complaint register page. Here we can see the IPC prediction page where the specific complaint is being provided and the predicted IPC sections are shown alongside the infographics for visual representation and understanding of the detected IPC sections. And this is how our data is stored in Excel sheet for the police authority side of view. So police can register hundreds of complaints a day and they are automatically stored in an Excel sheet which can be forwarded to higher authorities for bulk processing along with the predicted IPC sections. So the conclusion is that the system which we have created saves time during FIR filing, reduces manual legal workload for police and authorities, improves accuracy in IPC section detection, and addresses the growing need for more accessible legal support. This project, Juris AI, leverages AI and NLP to simplify FIR analysis and make legal processes more efficient and accessible. So the future works consist of incorporation of deep learning models like using BERT for improved accuracy, integration of multilingual FIR support. So as we know, we have more than 50 languages in our nation. So we need to implement multilingual FIR support, case history and analysis for better tracking of FIR patterns for improved legal recommendations, and feedback and rating system, which is more like a reinforcement learning type of thing for better accuracy and recommendations in future. So these are the references which we used. And thank you. Any questions? Thank you. Can you tell me how does your system handles the class imbalance problem? Okay, so for that purpose only, we are creating the synthetic dataset on which our model is trained. So for each and every IPC section, we have created 10 to 15 specific FIR complaints, synthetic FIR complaints. So the model does not get any imbalanced dataset. Then practically how many different classes you may have in the reality? So there are total 511 IPC sections, and for each we have 10 to 15 complaints, synthetic complaints. Okay, do you have any real world data available to test your model in real world scenario? No, we do not have much of real world. We have 5 to 10 complaints which we got from the local authorities, but we don't have much of a real FIR complaints. Okay. Thank you.
Thank you, sir. Moving forward, I would like to request Sir Athar Gaikwad to kindly present his paper titled Meter-Based Regulatory Technology for Auto Rickshaw Pricing, RTO Compliant Fare Locking and Prototype Evaluation in Pune. Do we have you here with us, sir?
Yes.
All right.
Am
You
I
can share
audible?
your screen now.
Yeah. I hope it's. I hope you can see my screen.
Yes, your screen is visible. Uh, okay. Yes.
Yeah. So, good morning. I'm Atharv Gaikwad and I'm from Pune. I'm a student, and my paper was on meter-based regulatory technology for auto rickshaw pricing, which is RTO compliant, fare locking, and prototype evaluation in Pune. So basically, I'll start with a very basic introduction. Most people have traveled by auto at some point, right? I personally travel around 14 kilometers every day from my house to college, paying a certain amount and the same amount while coming back. And I usually take the same route and I book autos through Ola, Uber, or like Rapido or other aggregator apps. So recently, if you have seen the news, especially in Maharashtra, auto drivers have been protesting against these apps because they take a high commission from drivers. So, due to this, many drivers have switched back to meter based pricing, which is fair and acceptable. However, when this change happened, my team and I noticed something unusual. On some days, I paid 50 rupees more than usual, and on some other days, I paid almost double the amount for the same route. This clearly showed that some meters were being tampered with and the price were higher than the RTO approved rates in Maharashtra. So this is where the idea for our project came from, to create an app which implements genuine meter based pricing, which is transparent, fair, and beneficial for both. So coming to the next slide, uh, I'll just brief you. Auto rickshaws have been associated with urban transport for a long time. So the state authorities, which is RTO, they have created the standard fare pricing model, which is 26 rupees for the first 1.5 kilometers, 17 rupees onwards for each extra kilometer, and a sudden 25% rush surcharge from midnight to 5 a.m. So these laws are present to ensure passengers get fair prices. But the issue over here are the aggregator platforms. Some studies which we read indicate that Ola and Uber drivers undergo algorithmic fare fixing. So they use other algorithms instead of these meter based algorithms. And they also take a lot of commission. These apps take like around 30-40% commissions from the driver, and so basically it does not help the driver much. So we did have a study. So 87% of the drivers felt exploited by the commissions. And I guess this is the reason why most drivers have shifted back to meter based pricing models. Also, people are making reels and like a lot of chaos, especially in Maharashtra and cities like Pune and Mumbai. So, our objective was to create a commission free platform as well as implement government approved meter rates. So the mathematical fare calculation algorithm was pretty simple. The first 1.5 kilometers was 26 rupees and onwards 17.14 per kilometer. And during night, it's like 25% extra charge. And the technology which was used in this app was Flutter for a full stack app, Supabase for the backend, and Google Maps API for the calculation of distance. Also, this is a study. We had taken 14 rides into consideration. I'll talk about why it was 14 first. It might sound like a small number, but it was actually really high. Why? Because most of the drivers which we studied were low digital literacy. So there was distrust from the respondents and the fear that the information would be misused. So when we approached these drivers, they thought that they might get scammed if they, like click our link or to fill the form. So this was the reason why we had 14 drivers only. But still, it was a considerable amount because no one had done a study like this before, at least in the last 8 or 7 years. Uh, so after this, the key findings which we found were like 94% believed that aggregator platforms prioritize profit over their driver welfare. 97% expressed a preference for commission free applications. And again, 42% respondents were frequently overcharged, 46 were experienced it occasionally, and also like overcharging was seen in more than one third of the rides, and around 3% of standard deviation which we noticed. As you can see on the left photo, basically it's not clear, but I'll tell you, this is a photo which I had taken. It was showing time in PM during daytime, so it was actually taking surge pricing of 25% on meter. So this is basically a system fault which we tried to overcome. And in the app, as you can see, Rapido for the same distance was showing 92 rupees. But when we saw it in our app, it was showing 77 rupees. So again, these apps were taking a lot of commission and they were not accurate. So again, 100% of the drivers which we asked, they supported our app to stick to the RTO fare structures, and also like 46% occasionally thought that they were getting overcharged, and there was also a discrepancy in passenger trust in government approved meter, which we overcome in our app. So methodology was basically that in the app it was simple. You start with your location and you choose your endpoint, and the distance is calculated using API calls of Google, and it is shown with a fee receipt, and everything is shown in the receipt, like as you can see, base fare per kilometer rate, distance charge, night surcharge, everything is calculated and is shown to the passenger. And yes, we had made a simulation as well over here, and the results, basically the accuracy was within 0.5%, and most of them aligned to our app, and almost 100% of the drivers said that they will definitely choose our app over any other aggregator platforms. And yes, that is it from my side. So basically, the conclusion, what we solved was exploitation via high commissions, surge pricing, and fare tampering. And what we built was real-time GPS-based, meter-based fare system. And we also proved that it was accurate, more respected, and 97% were ready to abandon the existing platforms. So yeah, thank you.
Can you tell me how the system handles the GPS inaccuracies or the signal loss, specifically in the dense urban areas?
Yes. So basically, uh, we had used normal Google Maps API for this, and Google Maps API usually handles all these parameters which you said, like have a sign calculation was used. There's this formula called have a sign which calculates the distance between 2 points using vectors. So this is taken into consideration in the API.
Okay, thank you.
Yes, thank you.
Thank you so much, sir. Thank you, yourself. Moving forward, I would like to invite Sir Nikunj Pal to kindly present his paper titled Smart and Early Detection of Stress in Individuals with Autism, a comparative study of learning algorithms and hardware implementations. Do we have you here with us, sir?
Yes, ma'am. I'll just share my screen.
All right. Yes, you can share your screen now.
I hope it's visible, ma'am.
Yes, it's visible. Can you put it in slideshow mode?
Yes, just a minute. Yeah, is it visible now?
Mm, yes, it's visible. You may start.
Okay. So a very good morning to all the members. Myself, Nikuj Pal. I'm from Vivekanand Education Society's Institute of Technology College, Mumbai, and currently in Electronics and Telecommunication branch. So today I'll be presenting our review work titled Smart and Early Detection of Stress in Individuals with Autism. So this work is also co-authored by Saili Gage, Amen Nimishe, Shravani Sawant, and myself. So our study basically looks at how wearable sensors and machine learning are being used to detect stress early in individuals with autism spectrum disorder, which stands for ASD, and what works well and what still doesn't works well. So before this, I'll quickly walk you through the motivation behind this work and explain what exactly we have reviewed and how we have done it. Then share the key insights from comparing existing systems, then followed by major gaps and what all we observed, and at last, the conclusion. So first, let's understand why this problem matters. So individuals with autism often struggle with emotion regulations, especially stress. So the challenge is that the stress in ASD is often non-verbal. So it doesn't always show up clearly through their behavior. So most traditional approaches rely on the caregiver observation, which is quite biased and subjective, which usually detects the stress after it has been escalated into a meltdown. So this delay limits the timely interventions and the therapy sessions. So with the rise of wearable sensors, we now have the ability to continuously monitor signals like heart rate or skin conductance and integrate it with machine learning so we can objectively identify the early stress pattern, and that's where the intelligent monitoring system comes in. So this is what motivated us to do this review. So talking about the aim, the main aim of the review was quite simple. It was to basically analyze how existing variable based and intelligent systems developed specifically for stress detection in individuals with ASD. So we focused on three major things. First, what psychological signals are being used. Second, which machine learning or deep learning models work the best. And finally, how practical these systems are in real world use. So, to give you a gist, what we found out is that while many systems show strong performance in certain settings, but there were several other challenges as well. So, talking about the review methodology, how we conducted this review. So, we analyzed research papers from major databases such as IEEE, Springer, Elsevier, ACM Digital Library, and MDPI. So, we included studies between the years 2012 and 2025 so that the study papers are more recent. Uh, and these papers specifically focused on ASD related stress or emotion monitorings. And then in total, we've reviewed more than 20 papers and comparing them based on sensors used, algorithms applied, and system architectures and other performance metrics. So talking about the focus and coverage, so let's actually focus how these studies work on. So from a sensing perspective, heart rate and heart rate variability along with GSM or EDA consistently appear as the most reliable indicators of stress in people with ASD. In terms of hardware, wrist-worn devices like smartwatches dominated because they are more comfortable and suitable for continuous use, and most system followed a basic common architecture, which was wearable device integrated with mobile app and then cloud, so which allows real-time monitoring and caregiver alerts. So algorithm wise, traditionally ML models like SVM and RFC was widely used, but CNN and LSTM based deep learning models became more dominant due to their ability to capture temporal patterns in psychological data. So this was all the coverage of the things that all the things that we have covered in our review. So let's compare what all things did we observe. So As shown earlier also, wrist-based variables were the most common form factor, and GSR, EDA, and accelerometers were the most commonly used sensors along with heart rate sensors, indicating their robustness for stress and activity monitoring. In terms of application, the most system focused on stress detection, activity recognition, and ASD monitoring. Some papers also showed how we can also integrate alerts, real-time alerts, as well as SOS buttons. A key takeaway is that multimodal sensing combined with machine learning or deep learning model significantly improves the accuracy. But at that time, most studies were still limited by small databases and long-term real-world validations. The figure below shows different parameters like the wearable devices form factors which were used in studies or the distribution of sensors in how many number of papers have used the same sensors. Talking about the research gaps and challenges that we found, there were several challenges that we could see. First, many models were trained on smaller synthetic databases, which limits the generalization. Second, psychological responses were greatly across individuals with ASD, which make the personalization very difficult. Third, the hardware issues like battery life, comfort, and connectivity. These were the main problem with the hardware, which probably affected in long time usage. Um, Also, very few systems go beyond detection to provide validate real time interventions. So there were false alerts and false recognition as well. Finally, there were also some privacy concerns while using a third-party cloud API or some other services, which often mistreated the data and probably caused a misconception. So, talking about the future research, what could have been done? So, based upon these findings, there were a few clear directions for the future research. There's a strong need for large-scale multimodal data sets with better diversity, and improvement in hybrid learning approaches can reduce the latency and improve privacy. More emphasis should be placed on long-term usability studies, which also involve caregivers and the therapist. And finally, integrating stress detection with intervention mechanisms like coaching or some video games to help the children reduce stress can also significantly impact the approach. In conclusion, wearable sensors combined machine learning offer strong potential for detection of stress in people with ASD, and psychological signals such as heart rate or EDA, which is electrodermal activity, or temperature, are quite useful. However, challenges related to generalization and hardware designs need to be addressed. So these are all the reference papers that we went through. Thank you so much.
You have you come across any data privacy concerns in your literatures while studying about this problem?
Yes, so there were quite few privacy concerns. First, in few of the papers, they have used some third-party services for the integration of sensors with the app, which basically leak the data in a way that they were not able to correctly make the data flow into the system. But they were, apart from that, they were also able to add their own predicted data. So that was also a thing which basically affected the long-term therapy.
Okay, what are the key challenges that you came across as far as deployment of these systems are concerned in the real world?
So the major key challenge is the wearable device, because people with ASD are often considered to be hyperactive. So the perfect form factor for this device was a major key challenge. There are many studies that showed various options that one could opt for, like the belt or cap, but still there's no significant study that proved that this one particular form factor of the device is the most suitable.
Okay, thank you.
Thank you, sir.
Thank you so much, sir. Just a second. And with that, we have come to an end of this session. I sincerely thank all the authors for their excellent presentations and contribution in this session, and all our participants for being part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We'll be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. I would also like to thank our session chair, Dr. Amit Thakur. Has a small token of appreciation, sir. Just a second. Yes. From the team of Global Knowledge Research Foundation and team ICTCS 2025 and the partners. Thank you so much for your valuable presence. Um, I would just like to request you if you have any closing remarks for the presenters or the team before we conclude the session.
Okay, thank you for the invitations and gave me opportunity to listen this recent research areas. I must congratulate all the authors for their crisp and very clear presentations, and many of them have potential to solve many real world problems and having societal impact. So I request all the authors to continue with the research work and add more maturity to that and just help the society and human beings to do a better life. Thank you. Thank you once again for ICTCS and all the authors.
Thank you so much, sir. Thank you, everyone. Before we conclude the session, I request everyone to kindly open their cameras so that we can take a quick snapshot before we end the session. Yes. Thank you so much, everyone. Have a great day.